Hello, everyone. I am Aditya Prakash, and I work as a senior DevOps Engineer 2 here at GeekyAnts. And my topic for today is a comparison between K8s, the traditional Kubernetes architecture, with its lightweight alternative K3s. So, in this video, I'll be discussing mostly upon how K3s has made itself lightweight, what has Rancher done in making K3s lightweight, the architectural differences, uh, how at GeekyAnts do we create an architecture around Kubernetes using K3s, and lastly, uh, discussing K3s as a business point of view. So to begin with, uh, before that, I would agree to the fact that Kubernetes, the traditional K8s, is really powerful. But yeah, uh, the traditional K8s does require a lot of reinvention. And why does it require so? The first point being it's resource heavy. So if you would go through, Google or some documentations, the official documentation of Kubernetes, you would find that a single node Kubernetes cluster roughly requires 4 CPU and 16 GB of RAM. That really makes it resource heavy. Some of its inbuilt features, some of the libraries, some of the extensions that it uses makes it really resource heavy and a bit difficult to set up on systems that have really low resources. Because of the fact that it's resource heavy, it does come with operational complexity. So somebody who even knows about Kubernetes, knows about the core concepts of Kubernetes, also faces a bit of difficulty when handling a self-managed Kubernetes cluster, bringing in a lot of operational complexity and difficulty in managing of the resources and the cluster. Again, cloud entirely, the price of the cloud depends upon the amount of resources you use on it. Maybe even if it's your own data center, we need to control the cost. And Kubernetes, because of the fact that it uses a lot of resources, hardware dependencies, hardware and software dependencies, it comes with a, what do you call it, a higher cost. Also, say, I'll summarize the last 2 points. Say maybe you are a hobbyist or you have a very small project, a small company who has, cost barriers. Maybe you are just a developer or an infra guy who wants to explore the features of Kubernetes. But because of the fact that the setup and all those things have a high learning curve and the cost barriers, this does pose people who are people who just want to explore Kubernetes, this proves to be a barrier to its adoption. Because of this fact and it being a bit large as an infrastructure on its own, this is not usually recommended for edge or small deployments or for somebody who just wants to learn and look at the features. So now coming to the main point, what is K3s? So as I've written, K3s is a lightweight, fully compliant Kubernetes distribution which completely works as an alternative to the traditional K8s. First of all, a very good name given to K3s by Rancher. K3s is something that was developed by Rancher. And that's really a great name because as you can see, 3 is less than half of 8. So K3s of all the problems that I discussed here reduces all those things to less than a half as compared to the traditional K8s architecture. So let's dive a deep dive bit into how K3s helps us. So what makes K3s lightweight? It has a lot of pointers, but these are some of the few pointers which I find really has made K3s stand out. First is the removal of in-tree cloud providers. So as you know, Kubernetes does provide few in-tree cloud providers for AWS, plugins for Azure, GCP, and other things. So what K3s has done, it has removed those part completely from the Kubernetes code base and does give you options to use external plugins, external providers, which we can, just plug in and play in our existing K3s architecture, thus making the code base really lightweight. K8s used to come with a lot of alpha features. Some of them were maybe unstable and unused, and that also increased the K8s code base to a larger size. Removing those again mattered the most when it came to making K3s lightweight. A Docker shim. So as you know, Kubernetes used Docker as their container runtime environment. So what K3s has done, it has completely removed Docker with and replaced it with Containerd, which is really lightweight. Next is the very heavy etcd. The etcd data store is used in Kubernetes to handle the current state. It keeps the current state of the Kubernetes architecture. Whatever is happening inside the cluster is stored inside etcd. So it has replaced it with a default SQLite. So SQLite, as you all know, is really lightweight, and replacing etcd with SQLite has also decreased the size of K3s. Kubernetes, the traditional one, used to come with a lot of networking components like IP tables for their network filtering, SOCAT for their network communication, and E tables. So what K3s has done, it has replaced these heavy components with their lighter alternatives. Kubernetes, one of the major things that K8s had was giving us an option of a lot of storage provisioners to handle their persistent volumes. So K3s now only provides local and external options, local for their local disk storage and external options for their networked storage that was not Kubernetes specific. So using local and external usually solves most of the storage provisioners things, thus making K3s lightweight. Why K3s? Again, to prove that whatever was said earlier, the binary size of K3s has come down to less than 100 MB. That means with bare minimum specifications, you don't even need a virtual private server. Even in your local, with hundreds of application and things running on it, with less than 100 MB of binary size, it really becomes easy for anyone and everyone to boot, maybe just for testing a single node K3s cluster. Because of its size and various heavy components being removed from it, the resource usage also comes down. Next thing is the control plane. As I said, that it uses embedded SQLite. Some of you might feel that what if you want to go ahead and start using Postgres? Yes, does it. K3s does provide us an option to use external databases which can replace SQLite completely. Installation. If for users who have at any point of time tried to set up say a K8s cluster, maybe initially only, but you would have felt that pain because it's a bit difficult. But with K3s, it's just a one command setup. You just run one single curl command. It installs all the dependencies and sets up the master node, and also gives you a token which you can go ahead and add it into your worker nodes, making them agents to your K3s cluster. Also, the uninstallation process is also a one command line setup. And then once the cluster is set up, you can use the kubectl command line tool and get started with your Kubernetes architecture. The next thing is complexity. Because of the fact that it's so less resource intensive and the installation and setup, it's so easy that even if someone who has minimal knowledge on how to set it up and handle resource it becomes really easy for them to handle its complexity. Next thing, quite a few times in this video, I've used the word single node cluster. But yeah, K3s does provide us high availability clusters as well. You can have multiple nodes in different regions, multiple nodes across, different virtual networks. You can have separate K3s cluster across different regions in the cloud and have maybe say a central Istio in one of your clusters, and you can go ahead and start, managing all the clusters very easily and without thinking about the resources that it's going to use and the cost complexity. Next, just to give you a visual representation as to how it looks, and I've taken this diagram very much from the official documentation. So as you can see, this is a K3s server to which a K3s user or a K3s manager, DevOps, or an infra guy interacts using the kubectl CLI. The main K3s server has SQLite database, And all the agent nodes and cluster information gets stored inside this. Whenever there is an external traffic, it gets routed to a load balancer, and it's the duty of the load balancer to now route the traffic to any agent node wherever the application is up and running. So it's very much similar to K8s, but yeah, it's lightweight. So here at, say, GeekyAnts, this is how we structure the entire application. It's a very basic architecture. We have our Kubernetes cluster up and running. We have a master node. We have few worker nodes present. We have various services along with their pods running on them. We have FluentD, which gathers all the logs from it and sends it out to a centralized logger service. And we also have Prometheus and Grafana dashboards to handle our monitoring. We do have a management node. In this management node, we usually maybe keep the code, the CI/CD overheads, and the ENV management. And on top sits our L7 or L4 data load balancer. You can, if somebody is from the AWS background, you can think of this as an ALB or an NLB. If somebody is, say, from Azure background, you can think of this as an Azure App Gateway. And if not, if you are somebody who is just into Linux, this is something what your HA proxy in L4 and Nginx in L7 will do. So this usually takes in the incoming traffic, and then based on the host name or the IPs, directs the traffic to the required service that is running on any particular node of the cluster. Again, Kubernetes, with similar to Kubernetes principles, we can go ahead and start attaching as many nodes as possible and have scaling in place as well. So this is a very basic architecture, how we usually design it for most of our clients. Now, coming to the very important part, because the technical aspects are something that you will get to know when you Google it. But these are some of the things that we ourselves have tested and it has really helped us out. Coming from a DevOps background and working for a consulting firm like GeekyAnts, having a business point of view for any architecture or any plan that we make really is very important. And K3s has really helped us in streamlining most of our processes. So the first thing that is usually a bottleneck when it comes to our client pitches, pitching it to be it anyone, is cost. So I have done a very small cost analysis. So I'll also tell you the assumptions. Assumptions here are, it's just a single node cluster. This does not have any particular application installed on it. It's just a single node cluster setup. The first one is a K3s single node cluster on a simple EC2 machine. The next one is K8s single node cluster on an EC2 machine. And the last one is using managed Kubernetes services, because these are the 3 or 4 solutions only where you can go ahead and set up your cluster. So when we set up K3s on EC2, as you can see, we can use a very small machine, that is a T3 micro, which is roughly $10 a month. But on the other hand, if we start using Kubernetes, maybe on EC2 or even management, you can see the drastic increase in drastic increase in the cost that it has. So this is just for a single node cluster. Just imagine if you start deploying application and start scaling, the cost of these are going to grow exponentially. And for small businesses, for someone who is trying this, but this really becomes a bottleneck. Again, K3s at any point of time, it's not like that it's not recommended for big businesses. It is also recommended for big businesses, and we have used it in various of our clients' projects. So next, coming to the second point, easier local simulation. So when it comes to DevOps, a usual term that we see here and there, most of us have also experienced that it's working on my system. Because what usually the dev team does, they go ahead, they create an application, run it on the local host, push it to a version control system, which triggers a CI/CD pipeline, and things get deployed onto the cloud, your personal data center, wherever you want it to be exposed to the internet and for other people to use. So it works on my system is a huge problem that infra people or people who are managing the cloud they face. Because so how does K3s solve it? K3s being so lightweight, a developer can go ahead, set it up on their local system, do a dry run there itself of how their application is behaving before pushing it to the production ready environment. So it's basically, adding an additional environment, additional test environment before the application, and that too, that environment is completely free of cost without pushing it to a production ready environment. So easier local simulation. So this also bridges the communication gap between the dev team and the ops team. So how it behaves on your local system, 99% of the time it will behave the same when it goes to a production ready K3s cluster. Next point being bring in standardization. Cloud has a lot of solutions. We to ourselves suggest a lot of solutions based on what client request do we get. But we needed to have standardization in place. We needed a single point solution which we can start pitching to clients, whether they want edge solutions, whether they want their application to run in different regions, whether their application to be so big that we have to set up multiple clusters, or be it maybe say a MVP or a POC project for some of our clients. So K3s can work as a solution for each of the cases that I just discussed. Even if it's growing, we can easily predict what the cost will be, considering it to be less resource intensive and the fact that it takes in less cost. So it has really helped us bring in standardization for any and every project that we deploy and we take in here at GeekyAnts. The last one is it does save us a lot of time and efforts. So what I did is I just provided, say, a group of developers, a group of fresh DevOps guys who had never worked on K3s and K8s, a group of another senior DevOps engineers. I provided them with the documentation, the required Kubernetes manifest, service, and deployment files. I provided them with Docker images, and I just asked them to go ahead and start setting up Kubernetes on whichever machine they like. So we also did time count onto how much time do they take and how much doubts are they coming up back to us with. So it was a very small analysis, and we found that roughly to set up a K8s architecture, it took them roughly 45 minutes because they needed to have certain hardware requirements in place, certain network and certain storage components in place to set up the K8s architecture. Whereas K3s, it was so easy that most of them were able to average roughly 10 minutes in setting this up. And also the doubts that came in during the cluster setup of K3s was relatively less as compared to what it came to Kubernetes, traditional K8s. Lastly, app deployment. App deployment, I would say, is pretty much the same, but my analysis says that people took more time in deploying application to their K8s architecture than to their K3s architecture, probably because maybe they were worn out after having to set up the K8s architecture. So probably this made them take some more time in deploying the application stack as well. But as you can see, there is less than half of the time it took for them to set a cluster and deploy an app onto it. So this is what actually also happens when we are taking in projects. It does helps us save a lot of time and efforts, thus improving our customer relations and improve our pitch decks. So yeah, this is it. This is how I feel K8s can be replaced by K3s in most of the scenarios, and how it has benefited us, and what are the major drawbacks that K8s had and K3s has solved it. So to end, I would not say that K8s is a thing that someone should not use. K8s in all terms is the powerhouse of container orchestration. But in today's world, K3s is the sprinter, is the faster, lighter, and ready to go ahead and deploy your containerized applications. Thank you so much.